these groups. Do you remember which one it was? It was like the oxygen. So the oxygen were like more on the neutral bridge. And the NH3, this blue one, had like a positive charge as well, if you remember. It was a new group. So I assume it would be that. And the green on the non-polar region. Non-polar, yeah.
That
on,
needs to go
yeah,
on
it
the
should be like
federal
this, right? Yeah, if it's non-polar, it should be like
on the benzene.
yeah, it should be that one.
The
Yeah.
program was very fussy with that.
Oh, yeah?
Yeah.
And when you did this with the students, also had like these problems of the program with some bugs and that for example, the ball sometimes the molecules stay in your hand and then they move.
Yeah, this one had more bugs in it, but it also it only sort of recognises if you're precise in the right spot. So a lot of students will put on the CH2 and they didn't recognise the CH2, it had to be on the benzene ring. And so they were always just looking at the central carbon. It doesn't work if it's there, it has to be in there.
And at the end, he didn't report those findings in
Sorry?
He did not report those findings in the
He
paper.
did not. This program was the one that was restudied.
Yeah.
We didn't go through and analyse this as probably because the students weren't really challenged to the same extent. They were challenged by the bugs more than the learning.
Yeah. Really should the paper of how students respond to bugs in new technology. Alright, Happy?
Yeah, good. Well done.
One thing we did learn is that, for the DNL, we got dot points to work it out.
Yeah.
We originally had the same words in a paragraph. They couldn't do it.
Oh.
We just put the words in dot points, same words, and they could do it.
But what they need to do when it was in words in paper? I mean, do they need to draw?
Now they just exactly the same words determine DNL.
Okay.
But I think they weren't capable of reading paragraphs. They read the whole paragraph and forget what the first instruction was. When there's dot points, they do step 1, step 2, step 3.
Yeah, okay.
And then a paragraph, they read the whole paragraph and forgot what they had to do at the beginning.
Yeah. And did many students fail to do the D and L here in DR, or most of them got it right?
In the end, they got it right, but they just couldn't progress.
Oh, I see. So I got
What you need to do is touch the blue and touch the red. No, the atoms.
I think now 0, 1 is doing something right. Let me see how this is going to see what.
Okay.
Yeah.
So now you've got the two just looking at the electron density maps.
I really forgot how hot this thing gets, how warm it gets.
Yeah. And if you press this submit button, you get to play with the trace receptor.
Yeah, the same thing that we were saying, that they are the mirror of each of them, and the electron density maps, they still, and even though they are the same structure, they have the same electron density in each of the molecules, their structure and their spatial distribution is different, right?
Oh. Test the receptor.
Yeah.
Oh
yeah, it's true. No way to see how we can improve those sweet things receptor. So yeah, that's a good question. Like, so that this is the receptor. Right? Students understood that this was the receptor,
Mm.
this structure here. I think that's correct.
Mhm.
I think my mind will not fit. Not very, not nicely as you did. Because, I mean, we can put it this way, but these green areas are properly placed in this cave.
But you also need to have, if you look at the face receptor, the brown bit is net positive,
Ah, it's positive, yeah.
and the
Yeah.
other bit, so you've got to match the charge.
Yeah.
So, the training alarm must fit to get the student test receptor.
Yeah.
So, this student can recept L training alarm.
The L does not fit.
Oh, this doesn't fit?
The L,
Doesn't fit?
no, yeah, L is the one that fits, right? No?
No,
No.
the D is sweet, L is very bitter. But you've got to match the charges. A lot of
Here's
students make the
positive.
mistake.
So positive is going to be negative?
Yes. I can't see what Bruno is saying.
So positive is here?
Yeah.
And
No,
then-
no, I think it's the other way around. Look at the taste receptor, because if you look inside the taste receptor, you can see what's inside.
Oh.
So there's like a benzene there.
That's an ammonium, I think. There's an ammonium.
Well, it's gray. So this-
Yes, but there's a plus. You see the plus on the top?
the-
That's a positive bit, the other side's a negative bit.
yeah. So that means that if
You
it's
need to
positive
have the
here,
inverse.
then it needs to be negative.
Yes,
So like this one?
yeah, and therefore the ammonium needs to go on the other side.
Or the ammonium. Ah. Like this? No. So that means that the L is not fitting here?
Yeah, it's not fitting because the hydrogen's in the way.
Ah, okay, so it should be
Yes,
like this.
and now it fits in better.
Ah, okay, okay, the hydrogen was the problem. Ah, okay. Is it?
You're looking at it from a different direction to Henry was looking at it, so
Oh, okay. So, yeah, basically in this position it fits a bit better. This enantiomer fits a bit better here in this receptor. This hydrogen.
This more sweeter one?
yeah, this is the sweet one. The other
Yeah.
one is bitter.
Ah, bitter.
It fits somewhere else and triggers the brain to say
Mhm.
bitter.
Or bitterness.
Mhm.
Alright?
Okay. Good.
Alright? So we basically mentioned that. Which enantiomer will fit. Well, we did it. Okay? I don't know if the prediction is so straightforward. I mean, in this section, when they need to predict, I don't know if it's too easy for them to say which one will fit there. I'm not sure.
Once the students recognise they need to get the plus with the minus and the minus with the plus,
Uh-huh.
then they're okay.
Okay.
And some people put the plus with the plus and the minus with the minus,
Yeah.
and then the L looks like it fits, but it's the charges should be repelling each other.
Okay. All right.
Again, what we could do with the
Ah,
haptic,
we need to have it there.
doesn't let you progress.
Yeah, oh no, that's good, that's good. It doesn't allow to progress. So now it's supposed to allow to progress. So just like this. Oh yeah, yeah. Can you please touch the green area?
Oh.
Oh. Already. Oops. Like. Yeah. This is the tip for learning. I thought this activity was more about the mutation of the receptor. More? I thought it was about a mutation.
No. It's
Rather
it's
than-
about the
Rather than D and L.
D and L. It's about the mechanism. D-phenylalanine is used in aspartame,
Yeah.
and so that's the sweeter component. Alpha-phenylalanine is actually very bitter.
Because when I did my undergrad, I remember we tried this. We tried the sweetness, but some students could feel it and others could not.
It
Because they have a
depends.
mutation in
It
the
depends
receptor.
on the sweetener. I think every taste receptor is slightly different.
Well, all right.
Okay.
Happy?
Good. Happy.
All right.
Thank you.
Okay, I'll take your hands first.
Oh,
Thank
oh
you.
my God, how it is. Stay there so much time.
It's warm. Yes.
Yes, right. Wow, how long did you stay there? Like,
Well, it's now 11 o'clock, so we've been here for well over an hour. Looking at probably enough for the eyes.
yeah, yes.
Wow.
Uh,
It's good.
Jacob told me about
Jacob?
Jacob. Have you known Jacob Martin?
Oh, yeah, I know him.
He told me about the study that people looked at VR and eyesight, and it was a concern that people who spend too much time in VR interferes with their capacity to. It develops myopia, short-sightedness, because you're looking here, even though you might be looking way over there, but you actually focus on the screen here. And people who spend too much time in VR, and kids who play too much VR games and things like this, they become short-sighted. There's a greater incidence of short-sightedness. I mean, you can't do a control experiment, but they advocated that you shouldn't be doing more than an hour a day or something inside VR.
Yeah, I agree. It's a bit tired.
Because you're focusing here, although you don't know, you think you're focusing
yeah,
there, but
focusing.
it's actually
You
a
said it
screen.
was a paper, or what was that?
He told me about it at one of the advanced science displays. At the end of the year, the advanced science students put on a display of what they've been researching.
I see.
And he had an advanced science student who was looking at carbon nanotubes.
Yeah.
And he was telling me about this, and he was concerned and tried not to have his students spend too much time playing in the VR
Yeah.
because of this.
Yeah, no, I agree. I agree. But I think, for example, have you tried Meta Quest the 3?
Yeah, he's got it here.
No, but this is 2.
No.
Oh, this is 3. Oh, that's very nice.
His students have 2 in the
Ah,
classroom, but he's got a 3 here.
Oh, I see. I think I have tried before, and I think it's much more comfortable because it's not very heavy and it's not so warm either. It's very light.
Yeah, very more clear.
Yeah, it's clear. It's and I think in some years there will be even better
Yeah.
headsets.
Well, even these swing. The first set we had to these set was a big jump. The first set had cables.
Oh, you have another set.
Yeah, we had cables that were connected to the computer, and when the 2 students who were in, had to have 2 of us running around to make sure they didn't trip over the cable. We kept moving the cable around.
That sounds very fun.
So the headsets made life so much easier, and the quality. I don't think the first ones had audio as well. I can't remember.
Yeah, this Meta Quest is. I think those are like breakthrough because it's mixed reality and it's very light. And I think
Yes, the fact that you can do.
and I think what the industry is focusing more now is in mixed reality rather than just virtual reality. I think they're investing more in mixed reality.
That kind of allows you to be in a laboratory, and it's in some respects safer because you can see where you're going, but at the same time you can see this piece of this molecule that you want that you're studying, and you're doing this in the lab, and you look on this side and you see the chemistry, and you can have both side by side. It goes fast.
Yeah. How do you feel?
Good.
You good? You like to try the other one?
Yeah. Final one. I'll try.
Well, do you think where you want to go with it, or you want to go today?
I don't mind. I mean, I like the protein one.
All right. I will change this one. I have some others here. Some spare.
But we'll move through a little bit quicker rather than
Yeah.
do the whole activity. So that's another 40 minutes. David hasn't responded, so that's
Yeah, I think he must be like maybe resting.
his back is normally he'll respond fairly quickly.
Yeah, especially in the mornings. Yeah, but he told me that he will take it easy because the pain wasn't getting any better. So,
He's done a lot of travelling, which is also not good for your pain.
yeah. Where is it? Is it this one? Okay. All right. Alright, in this case, you have extra functionalities with the controllers. You can change representation of protein in this way. Look, here's the controller. So I think if you press, there, you can see you have, you're pressing this top button. You can do some things. And I think the program will tell you how to change representation.
Yeah, the other handset I think changes the representation.
Alright. Just be happy.
One is for instructions and the other one is for. So there is an instruction screen on the side, but you can also have it on your controller. So you press the button and you'll see your own set of instructions instead of turning around to read the screen in vertical space. You can read it on the.
Okay.
Alright, so the head now give you the control. me give you the controller. This worked. Here's no problem with the left and right because there are no hands. Which is good. Alright, here goes the next one.
Well, this one you actually get controllers, you don't get any.
Yeah, that's a good. No left and right.
I'm really close to the grid.
You can you see him? Can you
No,
see?
I
Sue?
can't see salt at the moment.
Alright. So can you see it more?
No, I cannot see.
Alright. Okay, just give me 1 sec.
I have a big box in front of me.
Starts spinning.
But I'm near the edge.
Okay, just let me see. And
I
then
know the students got concerned, look up to see stars, but they look down, they don't see the ground.
Oh yeah, that was an initial prototype of the program.
Yeah, and they
Before
were a
the
bit
DC.
nervous when they were walking around because they couldn't see the ground.
More, I will take you out of the experience a little bit to make a connection, make the link with the other computer. Give me 1 sec. Okay.
Okay, I see.
Oh, I see.
I can see salt.
Can you give the controllers now? There's no left and right now. There's no problem with the hands.
Okay, the right hand gives me the instructions, and the left hand lets me change the representation. This is the start button.
Oh.
Continue button. Oops, I've gone back.
I will have, let's wait a little bit, maybe it's just, is it black now?
No, now it's blue.
Okay,
Now
it's coming back. It's coming back in brief, just give it 5 seconds.
It's here. Okay, so we need to make the molecule, and let's put the nitrogen in the middle, so we can start connecting things to the nitrogen. I don't think this, unlike the other one, it doesn't click.
Maybe not, huh? I'm
No.
not sure.
Yeah, this one doesn't have that same sort of click functionality. This is CH2. Yes, you don't have that capacity to move like the other one. It doesn't lock in. This was the first program we developed,
Oh, that's the first one.
so it's probably the one that's, in some respects, we were supposed to update it, but we didn't have the funding.
Oh, yeah, it's hard.
And this guy. Oxygen. in a CH2. Now, I don't know if you move it gently, you can, no you can't. It doesn't lock in, but that's your
Yeah.
structure of acetylcholine. No,
Something?
no, 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 it's not right.
It's not right.
No, because this one, then it's this one. That's what it says. So there's the acetyl, and that's the colour.
Something?
Okay. Okay, so we explained why we have the structure, then you press continue button. Well, how confident are you that we have the right answer? One is not very confident, 5 is very confident. Yeah, you are correct. So press continue. Yeah, the blue, where do you want to place that? So you've done the red, now where do you want to put the blue? Remember, this has got a positive charge, so electron pull, if it's positive, it's electron pull. Yeah. Well, you're closer, I think. Program might recognise it otherwise. Okay, press the submit button. Okay, the students will then explain that oxygen is electronegative, so electron rich. Nitrogen, because it's positively charged, it's electron pull. Mm. So if you look at this, you can see that this is electron rich, this part over here is electron pull, and the neutral bits, there's not much, but it's kind of over here.
Gray part is.
Yeah. This is the grey area. This is electron rich, this is blue. And, sorry, electron pull, blue, electron rich, red. Okay. And then you watch here the animation.
It's great.
So, yeah, we're forming a new bond here with breaking this one. We form one. Now we have a second molecule. And this is now color. So we, in the lab, that's how we do it. I
Break
like
it
that.
down.
Yeah.
Oh. Good.
This is the program.
Oh. acetyl sterilizer. This is acetyl sterilizer.
Yeah. This is the enzyme. Now, this is showing it as ball and stick, but we can show it as a mesh. And this is showing the surface only, and with electron density, the red is electron rich, the blue is electron poor, the white is neutral. But there's surface, a mesh, shows the same sort of thing, but it's a little harder to see.
What is the yellow one?
The yellow.
Must be sulfur?
I think they're the neutral bits on the surface, kind of white.
The
But
thing is that Moro, I think, Sul cannot see all the representations.
You can't see.
Look, change to yeah. Now he's seeing the same. He's seeing the full atom representation now.
Ball and stick.
Yeah, ball and stick.
Oh, okay. So maybe you need to change. So with your controller, the left controller, at the top there's a button that allows you to select.
With the other controller, Sul? With your other controller?
On the left.
Yeah, and then change it to with the path. Change it to another.
Yeah. Can you see different representations?
No, I think you cannot change it.
Well, no, I'm seeing him change it.
Ah, you're seeing how he's changing it.
I'm seeing it. I'm not touching it. So
Oh, he cannot. I mean, even though you Moro can see he's changing it, he cannot. He's still seeing the.
Oh, that's why
one
he
stick.
sees. Yeah, he sees the yellow ones and
Yeah,
the
the
sulfur
sulfur.
one.
Yeah.
And so
Yeah, it's. Can I give you a try, Sul, with the controller? Give me 1 second. It's okay. Just wait a second. Yeah, he cannot change it. He's
Oh, that's unfortunate.
Yeah, he's the same.
It's okay.
Yeah.
So I can see mesh.
No, I mean, but you cannot see
Oh,
the.
yeah. Mono can see mesh.
I can see the
Yeah,
mesh.
he can change it.
I can see the surface. Ball and stick. Ribbons. This is what you often see in the biology textbooks with the cartoon and the ribbon. So they're the different representations. I think if we move to the next step,
Yeah, move to the next one.
we'll see.
Oh, I can see mesh.
Okay, you now see the surface, right?
Yeah, no, it's surface.
So you see the surface where it's
Yeah.
mainly white with red and
Yeah.
Okay.
Blue.
so in the protein, if you look along here, can you see down there there's a deep hole?
Yeah.
That's where the chemistry happens, inside the hole. And somehow I should be able to, oh yes, I can make it bigger. So if you want, and you can walk inside if you want. Look around.
Oh, I see. I can see some label.
Yes.
Label.
Inside the, we'll walk. I'll make it bigger. Inside you can actually, we have labelled the amino acids that are most important for the reaction, that don't do the catalysis. I'm walking through a molecule here. So we need to place this where the hole is. So, yeah, that's the entrance to the gorge. Well, we chose it because it's got the big hole, right?
Yeah. I can see.
Okay, so zoom in, we have zoomed in. Walk into the protein, walk into the cavity. go inside and explore inside. Can I make it bigger?
우와.
Too short. I can't see.
Oh, I can grab.
Yes, you can move it around. Okay.
Oh.
Oh wow, this is really big. So this is the acetylcholine, and we need to put this in the hole to make it fit in. Now what I want you to do is put it at the entrance, and then where the direction in which you think it's going to fit. Now it bangs into this bit. So if you, I think it needs to go with this bit first, the red first. Going that way. Where the blue is next to the red bits. But the oxygen's going in first.
It's kind of complicated.
Okay, submit.
It's okay.
You see what happens. No, we got the oxygen, that delta minus bit is near the blue, the red's near the blue, and the blue is up here near the red.
Yeah, I can change.
Now, once you've
Once I submit, I cannot change it. Oh.
We just pushed it further in. See, this is the correct answer. We can't move this way.
This is correct.
And we should have had it something like that.
Yeah.
We went in too far. But
Yeah.
again, this is next to that, and this bit's next to here. Up here. So, they're in here.
Oh.
So you go in.
It's like a cake.
Yeah, you have to
Yes.
close.
So these are the amino acids. That's tryptophan, serine, I think. Yeah, serine, histidine, and the other one is down there, glutamine, I think. Glutamine. So these three are involved in the reaction, and this one is involved in attracting the positive part to this negative part, because you can see that this is quite red, so it's electron rich, and remember the acetylcholine had a blue part that was electron poor, so they get together. And down here we have an electron poor area, and that attracts the electron rich area of the acetylcholine. Now I've got to walk back out. It gets scary if you're going to fall off.
Yeah.
So place that on the electron poor area, and this on the electron rich area. So Now that's up the top. No, the top one, yeah, that one. And that one bit down a little bit further. The blue one.
Down the
Yeah,
corner.
yeah. About there.
Oh, we'll see, we'll see. How confident?
Okay, we'll explain.
You choose. Compare.
I think it's just matter of look, the blue was a bit a bit upper.
I think it's here, just that needs to get a little closer.
Not that there's like the shining.
Yeah.
Yeah.
That one's over here.
Yeah, that one is okay.
That's kind
The other one is there in this.
of over here.
Yeah, in serotonin.
No, that's bullshit.
Yeah. Yeah, no, that's. I agree. I agree. It's not correct.
I think it's that one that should have been.
Then there.
No, that's not.
Oh. So. Someone is talking. So.
Now what we need to do is put this one,
Oh.
take it through.
Yeah, but it's.
Okay, press continue. And now we need to. There you are.
Oh, 됐다.
Oh, okay. But we weren't able to move that one before.
This is. I can see the right answer.
Yeah, yeah. I tried to move that one and it didn't move, so I thought there was
Oh, or
but yeah.
Okay.
This guy needs to be because this is next to the
Wow, man.
yeah.
Oh, it's kind of complicated. Oh.
Oops. My lights have gone off.
Maybe let me see your battery. Or
Battery.
can you put out your battery to see if it's off? No, you still have one. You still have one light. It must be okay for.
Yeah, okay, now it's back.
Yeah. You only have one light though.
Yeah, that's
One
okay.
out of 4.
We're nearly finished.
Yeah.
So once we get to here, the students can see that everything is lined up for the enzyme to happen. And then when we press, you stay here and watch. When we press the button,
You have to get there and press play more.
oh, okay, now I'll come back.
Wow.
So here we can actually see the chemistry when it happens.
Wow.
Over here. And then we form the bond here. So that's the end. So it comes up here to react with this guy. Continue. So this bond gets broken. That takes it back. And then this that leaves. And then this
Far
is,
away.
yeah. And now this gets so the reaction is kind of finished. So
Oh, water is coming.
so
Oh. Wow.
fused.
Oxygen. 갑자기 transforming.
Okay.
Wow, that's done.
Alright.
Wow, yeah. So thanks. So
Let me get the controls. Give me 1 second. I will first get those controls. Yeah, now it works. It's good.
I'm not sure I agree with the chemistry of the animation. Henry and I have written a new one, but we never got a programmer to do it because we didn't have time to get it done for the data collection.
I see.
But there's a couple of bits there that are not correct.
Yeah, there and
So I was
many
looking
things
at,
going on.
it looked like serine had broken its carbon-oxygen bond.
Oh, really?
Yeah, and I said, no, it doesn't break.
Should not be
It
done.
had an ester, should have had an ester of serine, acetate ester, and then that gets hydrolyzed. That's not what they show. So
It shows the carbon oxygen breaking there. It shows.
yeah,
Yeah,
I was trying to work out. You've got a free acetic acid here. Why is it now reacting with another water molecule?